All right, this is a little bit of a revision after what you already know about refraction. I'm assuming that you can remember from your previous video that refraction is the bending of light, which happens when light moves from a dense medium into a less dense medium, or the other way around, a less dense medium like air into a more dense medium like glass, which is what's happening here. So if our bit of glass is not rectangular or triangular, but is oval shaped, as this one is, would be called convex. This is a convex lens, and the light would behave in the following way. We've got three incident rays that are all striking this curved glass surface at different points. Now, just like when our mirrors were curved, we draw tangents to the curve so that the tangent just skims the curve at exactly the point where the incident ray meets the glass. We do that for each incident ray. That allows us to draw the normal, where the normal line is perpendicular 90 degrees to the tangent. Imagine the incident ray traveling into the glass unbent, unrefracted. But you know that's not going to be the case. So the new ray will bend, because it's moving from a fast medium like air into a slow medium like glass. This ray is going to bend toward the normal, like that. On the other side, we have exactly the same process occurring. So we start by drawing a tangent to the curve at the point where the light strikes the surface. We draw a normal line that is 90 degrees to the tangent, and we imagine if the light ray passed unrefracted or unbent. But we know that's not going to happen. This light is going to bend away from the normal. So take a second in your head to imagine where that's going to be. Hopefully you picked something like that. All right. Now, in the next case, we've got a tangent line and a normal. But because this particular incident ray comes in on the normal, and so the angle to the normal is 0 degrees. The incident ray is approaching on the same line as the normal. This ray actually doesn't refract at all, it just goes on through. But the bottom ray will refract. So there it is if it didn't refract, but remember it will need to bend toward the normal, like that. And then at the other side, we get a tangent, we get a normal, and our refracted ray will bend away from its normal line. Our three lines will converge in one single point. So a convex lens is a converging lens. That gives us a focus to the lens. A concave lens is curved in the opposite direction. So we have our incident rays, we draw our tangents to the curve where the incident ray strikes, we draw our normals, which are 90 degrees to our tangents, and because we're moving from a fast medium like air to a slow medium like glass, we bend toward the normal. On the other side of the lens, we go through the same process. We draw a tangent and a normal, but then our refracted ray refracts away from the normal. Now this middle incident ray is approaching the lens at 0 degrees to the normal. So once again, it passes out through the lens unrefracted. Same as with the convex lens. But that only happens to one single ray, the ray that hits the lens at exactly the same angle as the normal line. Okay, and to our bottom ray, we get a tangent and a normal, and we refract toward the normal until we get to the other side of the lens, where our tangent and our normal show us that we will refract away from the normal, like that. Notice that these refracted lines are never going to meet. They're moving off in different directions. The rays are diverging. And that's what we need to know about refraction through concave and convex lenses.